Today we'll be going over the Unit 6 test review. Here we've got a pretty short test, kind of a quiz even. There's only 5 problems. For each of these, we'll be using the Law of Sines and Law of Cosines to solve for the missing angle measures and side lengths within each triangle. So let's begin with number 1. For number 1, I've got a triangle ABC. And here I've got A is 53 degrees and C is 96 degrees with side length C 27. Because I know an angle and its opposite side length, this allows me to use the law of sines. So that's where I'm going to begin. Let's use a law of sines where I'm doing sine of A over little a is equal to sine of C over little c. Filling in what we know, that'll be the sine of 53 degrees over some unknown side length, A, is equal to the sine of 96 degrees over 27. Here we will cross multiply. So we'll get A times the sine of 96 degrees is equal to 27 times the sine of 53. And then we'll divide both sides by the sine of 96 degrees. So A is equal to, let's put that in the calculator, 27 times the sine of 53, and we'll be dividing by the sine of 96. This is 21.68. So we will fill that in our picture here, as well as our answer over here. All right, then, see, I can find the angle measure of B next. That'll be 180 degrees, since the sum of all 3 angles must be 180 degrees. And I'll subtract the 2 known angles here. So I'll do 180 minus 53 minus 96. So B is 31 degrees. And lastly, I can use law of sines again to find the side length of B. So let's do sine of B over little b is equal to the sine of, let's use C since those were given to us, over little c. So this will be the sine of 31 degrees over some unknown B is equal to the sine of 96 degrees over 27. Again, we'll cross multiply and solve. So B times the sine of 96 degrees is equal to 27 times the sine of 31 degrees. And we'll divide both sides by the sine of 96. Okay, B is equal to 27 times the sine of 31 divided by the sine of 96. This is 13.98. It's close enough to 14. We'll call it 14. There we go. Let's move on to number 2. For number 2, I've got a triangle ABC. Again, I've got an angle and its opposite side length. So what that tells me is whenever I've got this occurring, one angle and its opposite side length, no matter which angle it is and its opposite side, I'm going to use Law of Sines to start out. So let's do sine of B's, so B over little b, and then C's, sine of C over little c. So let's start that up here. That'll be the sine of 25 degrees over 12 is equal to the sine of C over 28. We're going to cross multiply here. This will be 12 times the sine of C is equal to 28 times the sine of 25. And we'll divide both sides by 12. Let's see, this will be the sine of C is equal to 28 times the sine of 25 degrees divided by 12. This is 0.9861. And because we're solving for C and it's trapped inside of this sine function, we're going to do the sine inverse of both sides. So the sine inverse and the sine will undo each other, leaving C. And the right side here, we've got sine inverse. What we got there is equal to about 80.44. Yeah, we'll call it 80.44 degrees. So C is 80.44 degrees. All right, then I can find this angle measure because now I've got two of them. I can say 180 minus my two known angles. So subtract 25. Let's subtract 80.44, which we just found. So this is A is 74.56 degrees. All right, then lastly, side length A. We'll do sine of A's, so A over little a, and let's do B's because those were given to us to begin with. So that'll be the sine of 74.56 degrees over, I don't know what little a is equal to the sine of 25 degrees over 12. Again, cross multiply and solve. So A times the sine of 25 degrees is equal to 12 times the sine of 74.56 degrees. Divide both sides by the sine of 25 degrees. And let's put that in the calculator. 12 times the sine of 74.56. Divide that by the sine of 25. So A is 27.37. We'll round that to. All right, let's go on to number 3. For number 3, I've got this triangle. I no longer have an angle and its opposite side length. So let's see what I do have. I've got two sides and the included angle. So that's going to be the angle between those two sides. That means that I can use law of cosines here. I've got two forms for law of cosines. I've got the standard and I've got the, or it's traditional, I guess, and then I've got the kind of changed up, altered to find what the angle measure is, the alternative form. Here, I am looking for a side length first. Whenever you've got two sides and the included angle, you're going to look for the missing side length. To do that, I'm going to use the traditional law of cosines, starting with whatever side length I'm missing. So I'm missing b. So that means, here's the pattern. Start with the side length you're looking for. B squared is equal to, and then the other two sides are a and c. So this is going to be equal to a squared plus c squared, and then minus 2ac times the cosine of whatever you started with. So b, so then this will be cosine of b. Okay, so let's fill in what we know. B squared is equal to, a is 13, c is 17. So this will be 13 squared plus 17 squared minus 2 times 13 times 17 times the cosine of b is 34 degrees. And I can actually just plug in all of this into the calculator. So that'll be 13 squared plus 17 squared, and then minus 2 times 13 times 17 times the cosine of 34 degrees. Make sure I've got that all entered correctly. Looks like we do. So I'm going to hit enter. That's 91.565. So I'll say b squared is equal to 91.565. And because this is b squared and I'm solving for b, we're going to take the square root. So b is equal to the square root of this is 9.5689. We'll just call it 9.57. So b is 9.57 here. All right, now that I've got an angle and then its opposite side length, I can use law of sines to find the rest. So let's do law of sines here for, let's do a's and b's. So the a's would be the sine of, don't know what a is, over 13. This is equal to the sine of b is 34 degrees over, I just found this, 9.57. Cross multiply. This will be 9.57 times the sine of a is equal to 13 times the sine of 34. And let's divide both sides by 9.57. So here I've got the sine of a is going to be 13 times the sine of 34 degrees. Divide that by 9.57. This is 0.7596. And then we'll do the sine inverse of both sides, since A is trapped inside of this sine. All right, so A is equal to sine inverse of this is 49.43 degrees. And because I know two angles now, and the sum of all three of these must be 180, I can do 180 minus my two known angles. So that's going to be 180 minus 49.43. And let's also subtract 34. So then the last one, C, must be 96.57 degrees. Excellent. Let's go to number 4. So same as number 3, I've got two side lengths and the included angle, so the angle between these two. So that means I'm going to use law of cosines, and specifically I'm going to use law of cosines to find side length A, because that's going to be opposite of this angle that's known. Angle A is 52 degrees. So starting out again, that'll be, let's see if I can fit it over here. That'll be A squared is equal to B squared plus C squared minus 2BC times the cosine of A. So let's fill this in. A squared is equal to B is 30 and C is 23. So this will be 30 squared plus 23 squared minus 2 times 30 times 23 times the cosine of 52 degrees. This I can just put in all at once. So that'll be 30 squared plus 23 squared there we go, minus 2 times 30 times 23 and times the cosine of 52 degrees. Okay, so this is 579. A squared is equal to 579.387. And what we'll do here is take the square root, since this is A squared, to find A. A is square root of this 24.07. And now I've got an angle and its opposite side length. So let's go ahead and use law of sines now for A's and B's. This will be the sine of 52 degrees over 24.07 is equal to the sine of B. So angle B is unknown, over 30. Cross multiply. This is 24.07 times the sine of B is equal to 30 times the sine of 52 degrees. And we'll be dividing both sides by 24.07. All right, sine of b is 30 times the sine of 52 divided by 24.07. So sine of b is 0.9821. And then what we'll do here is take the sine inverse of both sides. Finally, b is equal to sine inverse of that, 79.157. We'll call that 79.16 degrees. And since I know two angles, again, do 180 minus the two known angles. So subtract 52, subtract 79.16. And the last missing angle, this will be angle C, is 48.84 degrees. All right, then number 5, we've got triangle here with all three sides known, but none of the angles are known. So in these cases where I know all three side lengths, but not any of the angle measures, I have to use the alternative form for the law of cosines. So I pick an angle that I'm going to start with. I typically use the largest side length and find the angle opposite of that. So we're going to find angle A. So this will begin, let's see if I can fit it in right here. Cosine of A is going to be equal to, and then you do the other two letters, so it'll be B and C. This will be B squared plus C squared, then minus A squared, all over 2BC. Okay, so cosine of A, this will be B is 16, C is 21, so 16 squared plus 21 squared minus A is 26, so 26 squared over 2 times 16 times 21. Okay, be really careful when you put this in the calculator. I'm going to do the top part separate from the bottom. So this will be 16 squared plus 21 squared and then minus 26 squared. Okay, so 16 squared plus 21 squared minus 26 squared, that's 21. And the bottom part is 2 times 16 times 21. So 2 times 16 times 21 is 672. 21 divided by 672. I've got cosine of A is equal to 0.03125. No, I don't want to solve cosine of A, I want to solve A. So I'm going to do the cosine inverse of both sides. And that'll give me A is equal to cosine inverse of this is 88.2 degrees. Okay, and now, once I've done that once, I now have an angle and its opposite side, which tells me that I can use law of sines. So we're going to do A's and B's. So we'll do sine of 88.2 over 26 is equal to the sine of B over 16. Let's cross multiply and solve here. So that'll be 26 times the sine of B is equal to 16 times the sine of 88.2 degrees. I know I'm going to do this part. So 16 times the sine of 88.2, and then I'll be dividing by the 26. All right, so I've got sine of B is equal to 0.615. And then to get B out of that sine, let's do the sine inverse. So we'll get B is equal to sine inverse of this is 37.957. Let's call that 37.96. 37.96 degrees. Finally, three angles add up to 180. That means I can take 180 and subtract 88.2, subtract 37.96, and we'll get 53.84 degrees.